Okay, so here we are looking at the electrostatic series. This is a mini lesson. And so far, we've talked about charging up an ebonite rod or a lucite rod by rubbing it with either rabbit fur or polyethylene. But we never really talked about why, when I say rub an ebonite rod with rabbit fur, do I get a transfer of electrons? And so that's what we're going to talk about today. We're going to answer that question, why? Why rabbit fur? Why ebonite? Why polyethylene? Why lucite? Why these things, and how come I get a transfer of electron? So we're talking about a concept known as charging by friction. Of course, we've looked at this before. When you rub two things together, you get friction. This is found in your textbook on page 473. So we're going to use the electrostatic series to determine the type of electrostatic charge, the type of electrical charge when things are rubbed together. Okay, so the transfer of electrons by friction. And this works best when both things are made of insulators. Okay, it works best when both items that we're rubbing together are insulators. So you can see right here, this chart is the electrostatic series right here. And substances that are higher on the list, okay, they're way up here at the top. These things have a weak hold on electrons. So we'd say these things have a weaker attraction for electrons. They're going to lose electrons. And so if they lose electrons, they become positively charged. And that's important to know because, of course, electrons are negative. And so if they lose electrons, they become positively charged. Substances that are lower on the list, those that are kind of at the bottom, these have a strong hold on electrons. And so these ones have a stronger attraction for electrons. And they're going to gain those electrons, and so that means they become negatively charged. All right, and you could have guessed that. So let's take a look at some of the things that are on this list. At the top, we have human skin, very, very weak hold on electrons. Rabbit fur, acetate, and you go down the list and you look at some of the things that have a very strong hold on electrons, such as ebonite, polyethylene, polyester, and so on and so forth. So the greater the separation between two things on this list, the better the electron transfer. Because there's a greater difference in the pull for electrons. Okay. So this is really, really important in some of the examples that we've looked at in class. And you'll notice right away, very close to the top of this list is something familiar. And at the bottom of this list is something familiar that we've used before. And so let's say we've got the exact two examples that we did in our lab. Static charges are produced using friction. Which pair of insulators will produce the stronger electrostatic charge? So we could look at ebonite and rabbit fur, and when we do that, you'll notice the difference between ebonite and rabbit fur. They're very, very separate to the opposite ends of the spectrum. So there's actually quite a difference in their pull. And when we look at, say, something else, lucite and polyethylene, they're pretty separate too, but they're not quite as far as the others. So if we were going to compare these two things, and we were going to say which will produce a stronger electrostatic charge, you'd have to go with ebonite and rabbit fur because they are farther apart. Okay, so what is polyethylene? This is just a little note. about polyethylene, the type of plastic that it is. Milk jugs, detergent bottles, margarine tubs, garbage containers, water pipes, or LDPE, plastic bags, film wrap, saran wrap, bubble wrap. And so there's basically two different types of polyethylene. They're plastics, okay? The recycling symbol with 2 and the recycling symbol with 4 are the different types. But any of these will produce an electrostatic charge when you rub them with lucite. So here's a couple of examples down below. We're going to use the electrostatic series, and we're going to determine which object will get the positive charge and which will get the negative charge. And we're going to show the electron transfer. So first, to begin, we've got rabbit fur and we've got ebonite. And when we look at this list, rabbit fur is, of course, up at the top. It has a weak hold on electrons. And so we would say then that rabbit fur would become positive, and the ebonite would become negative, and we will show the transfer of electrons from the rabbit fur to the ebonite rod. Okay. Very similar, cotton shirt and wool socks. So these are things that sometimes you put together in the dryer, and you'll notice that after you tumble them in the dryer, the socks will attract the shirt, i.e. they're stuck together, and we call that static cling. And perhaps you have noticed that, especially if you do your own laundry, which you should. All right, so here, let's do our example. We've got the cotton shirt over here, and we've got the wool socks over here. So let's go to our chart up here. We'll find cotton on the list. It's right here. And we'll find wool on the list, and it's right here. And of course, cotton and wool don't have as much of a separation, but it's enough that we do get cling. And so wool is closer to the top. So we'll notice that those wool socks then will pick up the positive, and the cotton t-shirt picks up the negative, and we show the direction of electron transfer. Electrons go from the socks to the shirt. All right, so here's another one that we can do. Silk scarf and a glass rod. Again, we've got the silk down here, and we've got the glass over here. And when we go up to our electrostatic series, we'll say here's silk right in the middle, here's glass up here, and we notice its separation is what it is, and we say, okay, well, the glass has a very weak hold on electrons, so the glass picks up its positive charge. The silk has a stronger hold on electrons, it picks up a negative charge, and we get electrons that flow from the glass to the silk. All right, and the last little example that we're going to do is a pet cat with a rubber kitchen glove. All right, so we've got, again, another example here. We've got the cat, and we've got the glove. And if we go up and look at our electrostatic series, we see cat fur, and rubber or latex down here. And so cat fur and latex, quite the separation. Cat fur has a weaker hold, so the cat picks up a positive charge. The rubber glove picks up the negative charge, and of course electrons flow from the cat to the glove. And that's exactly what we have. So after being, we'll fill in this last little bit, after being rubbed, the cat's fur, which is now, of course, charged positive, will stand on end. And it will repel each other because it's lost a whole bunch of electrons, and all the fur here is all positively charged. And the reason why fur or your hair stands on end, and think about the Van de Graaff generator that we used in class, that's because like charges repel. And if the cat is charged positive, and all of the ends and bits of its fur are positive, then it's going to, all those little bits of fur are going to repel each other, and the fur will stand on end. And that is your introduction to the electrostatic series.